We tend to think of our world as a finished map, a completed puzzle where every mountain has been measured and every valley named. But look closely at the blue stretches of our globes, and you will realize that we are living on a very thin crust. What if the distinction we make between the solid ground and the liquid sea is nothing more than a temporary geological coincidence? Underneath the crushing weight of the world's oceans lies a vast, silent geography that remains more mysterious to us than the moon. This is a story about the Earth's lost limbs, the massive continental fragments that were once high and dry but now sleep in the deep. For centuries, sailors and explorers whispered tales of sunken kingdoms and lost lands like Atlantis, hidden forever beneath the relentless, churning waves. While those myths may be the product of human imagination, the reality of the seafloor is far more grand and technically awe-inspiring. Imagine a planet where the water was just a little less plentiful, or perhaps where a few less icy asteroids crashed into our surface. In such a world, the map of humanity would be unrecognizable, featuring sprawling landmasses and bridges that today exist only as cold stone. The concept of sea level is not a fixed law of the universe, but a shifting boundary dictated by the chaotic history of our solar system. If we could pull the plug on the oceans, we would see that the continents do not simply end at the beach. Instead, they stretch out into the darkness, tearing themselves apart and leaving behind massive fragments of their own granite and basalt bodies. These are the microcontinents and submerged plateaus, the ghost geographics of a planet that is constantly recycling its own skin through fire. To understand how this works, we must look at the giants that survived the drowning, starting with a hidden titan named Zealandia. Hidden beneath the South Pacific, Zealandia is a nearly 5 million square kilometer fragment that challenges our very definition of what a continent is. If it were just a few hundred meters higher, we would be teaching children about an eighth continent sitting right next to Australia. Today, only 7% of this massive rock reaches above the waves, manifesting as the rugged peaks of New Zealand and New Caledonia. But 80 million years ago, this land was a sprawling, elevated heartland squeezed tightly between the massive silhouettes of Australia and Antarctica. As the tectonic plates began their slow, agonizing divorce, Zealandia was caught in the middle and stretched until it became thin and fragile. This stretching caused the land to sag and sink, drowning a world of prehistoric forests and leaving only the highest mountains as islands. Zealandia proves that land can die and become a ghost, but other land masses are currently in the process of being born. Deep in the Western Pacific, a different kind of geological drama is unfolding where the ocean floor is literally eating itself. When oceanic crust dives beneath another plate, it melts and triggers a violent, vertical response from the Earth's interior. This process has created the Isu-Bonin-Mariana Arc, a hidden mountain range spanning over 1 million square kilometers beneath the surface. To us, these look like tiny, isolated dots on a map, but they are actually the summits of 60 active underwater volcanoes. If humans had evolved just a few million years later, we might have seen a new, continuous Japan stretching far into the south. This is the Ring of Fire in action, a massive factory of land that works at a pace too slow for human eyes to track. But sometimes, the Earth doesn't just build slowly, it erupts with such force that it creates massive flat plateaus in an instant. About 120 million years ago, the seafloor between Australia and Antarctica didn't just move, it ripped open in a magmatic catastrophe. This led to the creation of the Ontong Java Plateau, the largest oceanic igneous province on our planet, born from fire and ice. Over 80 million cubic kilometers of magma poured out, enough to cover the entire United States in a layer of rock miles thick. Today, this massive basaltic kingdom is being slowly swallowed by the Solomon Trench, fueling the growth of the nearby Solomon Islands. Just nearby sits the Manahiki Plateau, another fragment of this ancient volcanic event that once stood proud above the waves. Imagine the ancient Pacific explorers sailing across thousands of miles of blue, searching for a horizon that had already sunk. Only 3 small coral atolls remain today, clinging to the surface like the last gasps of air from a drowning giant. Further out in the Pacific, the influence of plate boundaries fades, and we meet the enigmatic power of the hotspot. These are stationary plumes of heat that act like a cosmic blowtorch, melting through the moving crust above them to create chains. The Hawaiian Islands are the most famous result, but they are merely the youngest children of a much longer, older family. Beneath the waves, a trail of thousands of miles of eroded islands stretches all the way toward the edge of the North American plate. These emperor seamounts are the ghosts of a Hawaii that existed before the first dinosaurs ever walked the Earth. If we continue our journey, we find that the Pacific isn't the only place where the Earth has hidden its massive structural secrets. Crossing over to the Indian Ocean, we encounter a region that seems deceptively empty of land on a standard political map. Yet, looking beneath the surface reveals a jagged, volcanic graveyard that tells the story of a messy, violent continental breakup. The star of this show is the Kerguelen Plateau, an igneous giant that has been active for over 130 million years. At 1.2 million square kilometers, it is more than half the size of Greenland, yet it remains almost entirely cloaked in water. This plateau was born when a volcanic hotspot began pumping rock onto the floor of a widening rift between prehistoric continents. As Australia and Antarctica drifted apart, the hotspot acted like a messy divider, splashing molten rock on both sides of the gap. One massive chunk of this volcanic debris was carried away by the Australian plate, becoming a feature known as Broken Ridge. Thousands of miles now separate these two halves of the same geological soul, a testament to the power of tectonic movement. The small parts of Kerguelen that still peak above the waves today are frozen, windswept islands dominated by massive, ancient glaciers. But the northern reaches of this plateau sit much closer to the temperate zone, hinting at a world that could have been. Had the plateau stayed just slightly higher, it could have supported a lush subantarctic paradise filled with unique, exotic flora and fauna. We can only speculate about the civilizations that might have thrived there, perhaps a bridge between the Indonesian tropics and the south. Austronesian explorers, the greatest navigators of the ancient world, reached Madagascar as early as 350 BCE, crossing thousands of miles of ocean. Would they have settled this lost continent if it had offered a green horizon instead of a cold, grey one? Perhaps later, European explorers would have found a landscape resembling a second New Zealand, a hub of culture in the middle of nowhere. Right beside the ghost of Kerguelen lies another anomaly, a perfectly straight line of land running 5,000 kilometers long. This is the 90 East Ridge, a continuous volcanic scar created as the Indian plate sped northward over a stationary plume. If this ridge were above sea level, it would act as a massive, solid wall, splitting the Indian Ocean into two separate halves. Such a wall would have fundamentally altered the world's weather, blocking currents and changing the path of life across the entire globe. The Indian Ocean's floor is a scattered jigsaw of these tectonic casualties, born from the messy divorce between India and Africa. As the central Indian Rift forced the subcontinent northward, it left behind a trail of basalt, known as the Chagos-Laccadive Ridge. This massive underwater structure makes the Indian subcontinent look much longer than it appears on our standard dry land maps. On the other side of this rift sits the Mascarene Plateau, a 300,000 square kilometer graveyard of continental scraps. While only tiny specks like the Seychelles and Mauritius peak above the surface today, much more was once exposed to the sky. During the last ice age, sea levels were 130 meters lower, revealing a massive mid-Indian archipelago of green peaks. We often forget that Madagascar itself wasn't always a lonely island. It was once the centerpiece of a much larger landmass. Today, a submerged plateau the size of the island itself extends southward, reaching toward a point known as Walter's Shoal. This makes the greater Madagascar landmass the third largest lost continental fragment on Earth, spanning 1.1 million square kilometers. Even further south, the seafloor reveals the open wound where Antarctica finally tore itself away from the southern tip of Africa. This violent separation left behind the Mozambique and Agulhas plateaus, two massive blocks of tectonic debris sitting in the dark. Each of these submerged regions acts as a time capsule, holding the secrets of a world that existed before the oceans took over. Leaving the Indian Ocean behind, we round the Cape of Good Hope and enter the youngest of the Great Basins, the Atlantic. The Atlantic is often seen as a clean break, but its floor contains one of the most symmetrical volcanic anomalies on the planet. Extending off the coast of Africa is the Walvis Ridge, a 280,000 square kilometer volcanic peninsula. It was created by a hotspot that pumped magma through the mid-Atlantic rift as South America and Africa drifted apart. Mirroring it on the South American side is the Rio Grande Rise, an almost identical basalt deposit born from the same fire. Imagine these two features as a pair of massive, submerged arms reaching out to touch across the deep, dark Atlantic basin. If the Rio Grande Rise were above sea level today, it would be a lush, tropical island paradise off the coast of Brazil. These islands could have hosted unique rainforests and ecosystems, perhaps changing the entire course of South American human history. The Atlantic continues northward, where the mid-ocean ridge acts as a jagged spine connecting the world's most powerful tectonic plates. Here, at a rare triple junction, the North American, Eurasian, and African plates pull away from a single, chaotic point. This tectonic traffic jam has forced magma to escape in massive quantities, building the 250,000 square kilometer Azores Plateau. While we see the scattered Azores Islands as a tourist destination, they are actually the newest peaks of a landmass still being born. As the rift continues its slow, relentless expansion, this plateau will eventually be torn into 3 separate pieces, scattered across different plates. Further north, where the Atlantic meets the icy reaches of the Arctic, we find one of the most intriguing continental outcasts. This is the Rockall Plateau, a massive block of granite that was stretched and abandoned during the messy breakup of Europe and Greenland. Although it sits deep in the cold north, Rockall lies directly in the path of the Gulf Stream's warm, liquid conveyor belt. This means that if Rockall were above sea level today, it wouldn't be a frozen wasteland, but a lush, grassy neighbor to Ireland. Imagine a fifth Celtic nation, safe from the invasions of history, flourishing with its own unique language and prehistoric stone monuments. The humans who inhabited such a place would have looked out at the same stars as the ancient Celts, but on a vastly different map. Yet, as fascinating as these what-ifs are, they highlight a fundamental truth about our perception of the Earth's surface. We treat the coastline as a definitive border, an end to the world we know, and a beginning to a watery void. But the geology doesn't care about the water. The granite and basalt continue their journey regardless of the pressure above them. The true form of our planet is a messy, scarred landscape of tectonic wounds and volcanic eruptions that have been partially veiled. By looking beyond the water, we begin to see that Earth is not a static stage, but a dynamic, ever-changing sculpture of rock. We are simply living in a brief window of time where the sea level allows us to see only the tallest of these sculptures. Every island is a warning, a reminder that the land we stand on is subject to the same forces that drowned Zealandia. To study these lost landmasses is to study the mortality of continents and the ephemeral nature of our own terrestrial homes. It forces us to ask, how much of our history was dictated not by our will, but by the depth of the ocean floor? But what if the greatest mysteries of these lost lands aren't just geological, but biological, hidden in the deep, dark pockets of the unknown? For decades, stories have persisted of creatures that don't belong to our modern world, giants that seem to have stepped out of time. One of the most enduring legends is that of the Yeti, the abominable snowman said to haunt the high, frozen reaches of the Himalayas. To the local people of Tibet and Nepal, the Yeti is not a monster from a movie, but a real, albeit elusive, part of the natural world. They describe a massive, bipedal ape-like creature covered in thick reddish-brown hair, surviving where no human could ever hope to last. It is a shadow in the blizzard, a silent guardian of the peaks that leaves behind footprints far too large for any known animal. These accounts aren't just modern campfire stories, they are woven into the ancient fabric of Himalayan culture and religious art. Western fascination exploded in 1951, when explorer Eric Shipton photographed a massive, clear footprint in the snow on the Menlung Glacier. The image traveled the globe, igniting a fever of curiosity. Could a relic species of giant primate still be roaming our planet? This mystery exists because the world is much larger and more rugged than we often care to admit when we are in our cozy cities. Humanity has a deep, psychological need for the wild to remain wild, for there to be corners of the map marked, "Here be monsters." The Yeti represents our fear of the unknown, but also our hope that nature still holds secrets that we haven't yet mastered or destroyed. In the following decades, high-profile expeditions were launched, some even funded by eccentric millionaires and supported by famous mountaineers. They returned with hair samples, bone fragments, and scalps kept as sacred relics in remote mountain monasteries like the one at Kumjung. At the time, the evidence felt overwhelming. Surely, where there is smoke, there is a 500-pound ape man walking through the mist. But science is a cold, rigorous judge, and it eventually brought a new set of tools to the high-altitude crime scene. Modern geneticists, like Charlotte Lindqvist, decided to look past the myths and directly into the DNA of these Yeti remains. Using advanced mitochondrial sequencing, researchers analyzed 9 separate samples of hair, skin, and bone attributed to the legendary creature. The results were definitive, and for some, heartbreaking. Almost all the samples belonged to local bears, specifically the Himalayan brown bear. One sample even traced back to an ancient lineage of polar bears, suggesting a complex evolutionary history rather than a new primate. While the DNA points to bears, the mystery of the Yeti isn't solved so much as it is transformed into a lesson on human perception. If the Himalayas hide bears that look like monsters, then what secrets are held in the steam-choked jungles of South America? Deep within the Amazon rainforest, indigenous tribes have long spoken of a terrifying beast known as the Mapinguari. Described as a giant, hulking creature with reddish fur, a backwards-facing foot, and a second mouth located on its belly. It is said to emit a stench so foul that it can disorient hunters, and a roar that echoes like a thunderous groan through the canopy. For a long time, Western science dismissed these stories as mere folklore, the fever dreams of a jungle too dense to navigate. But in the 1990s, paleontologist David Oren began to wonder if the Mapinguari wasn't a myth, but a living fossil. He noticed striking similarities between the descriptions of the beast and a creature that supposedly went extinct 10,000 years ago. This was the Megatherium, or the giant ground sloth, a 6-meter-tall behemoth that once ruled the ancient Americas. These giants possessed massive claws, thick skin embedded with protective bony plates, and could stand on their hind legs to reach the trees. Could a small population of these megafauna have survived in the deepest, most inaccessible pockets of the Amazonian basin? The idea is intoxicating. The notion that a remnant of the Pleistocene era is still breathing just beyond our reach. To verify this, researchers have trekked through thousands of miles of mud and mosquitoes looking for scat, fur, or tracks. They use the tools of modern ecology, mapping out the biological corridors where such a large herbivore could theoretically find enough food. However, despite the compelling nature of the oral histories, no physical evidence of a living giant ground sloth has ever been found. Every Mapinguari sighting remains anecdotal, and no DNA or clear photography has emerged to challenge the official record of extinction. In the absence of a body, science looks for alternative explanations, such as the misidentification of giant anteaters or large monkeys. Perhaps the Mapinguari is a cultural memory, a story passed down through hundreds of generations from ancestors who actually saw the last sloths. This would mean the legend is real, but the animal is gone. A ghost story told by a civilization that never forgot its neighbors. It reminds us that our stories are often more durable than the flesh and bone they are meant to describe. If the Amazon hides ghosts of the Pleistocene, North America has its own titan of the timberline, the legendary Bigfoot. Known as Sasquatch to the First Nations of the Pacific Northwest, this creature has become a global icon of the unexplained. Tens of thousands of sightings describe a 7 to 10 foot tall primate covered in dark hair, possessing an eerily human-like gait. Unlike the Yeti's frozen peaks or the Mapinguari's humid swamps, Bigfoot allegedly inhabits the vast, temperate rainforests of our own backyard. The most famous evidence remains the 1967 Patterson-Gimlin film showing a large figure walking with a rhythmic, heavy stride through a creek. For decades, experts in biomechanics and Hollywood suit makers have argued over whether those muscles and movements could possibly be faked. Proponents point to the sheer volume of Class A sightings and plaster casts of footprints that show anatomical details like dermal ridges. Some researchers, like the late Dr. Grover Krantz, risked their academic reputations to argue that Sasquatch could be a descendant of Gigantopithecus. Gigantopithecus was a real, massive ape that lived in Asia hundreds of thousands of years ago, standing nearly 3 meters tall. The theory suggests they crossed the Bering Land Bridge alongside early humans, finding refuge in the dense, rainy forests of North America. It is a compelling narrative that bridges the gap between hard paleontology and the mysterious sightings in the woods of Washington. But as we move into the 21st century, the biological reality of such a creature faces an increasingly difficult mathematical hurdle. To maintain a healthy, breeding population, there would need to be thousands of Bigfoot individuals scattered across the continent. A population that large requires a massive amount of calories and leaves behind a significant amount of biological waste and remains. Yet, in over a century of intensive logging and hiking, we have never found a single bone, a tooth, or a grave. Modern science has also turned to environmental DNA, or eDNA, a technique that can detect a species from just a liter of stream water. Thousands of eDNA samples from the Pacific Northwest have identified bears, wolves, and humans, but never an unknown giant primate. Many scientists now believe the phenomenon is psychological geography, our brains interpreting shadows and stumps as the monsters we expect to see. We are hardwired by evolution to see faces in the leaves, a survival mechanism that kept our ancestors safe from hidden predators. In a world where every inch of the forest is mapped by satellites, Bigfoot may be the last refuge for our collective imagination. Whether it is a sunken continent or a hidden giant, these mysteries reflect our struggle to accept that we have reached the end of the map. We live in a unique era where the planet feels small and interconnected, yet the scale of geologic time remains almost impossible to grasp. The disappearance of the megafauna wasn't just a biological event, it was a psychological trauma that fundamentally changed how we see the wild. For nearly 3 million years, humans lived alongside giants, mammoths, saber-toothed cats, and ground sloths were our neighbors and our rivals. When they vanished at the end of the last ice age, they left a void in our collective psyche that we have been trying to fill ever since. This is why we see Bigfoots in the shadows and Yetis in the snow. We are lonely for the world that used to be. Our legends are not just mistakes or hoaxes, they are the lingering echoes of a time when the world was much more crowded with wonder. Science doesn't seek to destroy these wonders, but to ground them in the reality of a planet that is more complex than any myth. When we find that a Yeti hair belongs to an ancient bear, we haven't lost a monster, we have discovered a fascinating survivor of the ice. When we map the sunken mountains of Zealandia, we aren't losing Atlantis. We are finding a 5 million square kilometer testament to Earth's power. The truth is often more cinematic than the fiction, requiring us to look at the ground beneath our feet with a new sense of fragility. Plate tectonics tells us that even the most solid mountain is just a temporary wave in a slow-motion ocean of stone and heat. The continents are not permanent anchors, they are ships adrift on a mantle that is constantly rebuilding the world stage. We are the audience of a play that has been running for 4 billion years, arriving only in the very last seconds of the final act. It is humbling to realize that the geography we take for granted today is merely a snapshot in a long, violent film of transformation. One day, the land we call home will be a submerged plateau, a ghost continent for a future species to wander about and explore. Perhaps they will find our steel and glass ruins and tell stories of a mythical civilization that lived above the waves. In the grand scale of the universe, our cities are as ephemeral as a footprint in the Himalayan snow or a ripple in the Pacific. But our curiosity, the drive to ask what lies beneath the water or behind the trees, is what makes us truly significant. We are the part of the Earth that has developed eyes and a mind to witness its own incredible, disappearing history. Our journey from the sunken continents of the deep to the giant shadows of the forest floor eventually leads us back to a single point. It is the realization that our world is never truly static. It is a living, breathing entity, constantly reinventing and erasing itself. What we call eternal, the highest peaks or the grandest empires, are, in the geological blink of an eye, merely temporary flickers. But within that transience, our ability to observe and remember transforms silent stones into stories with a soul. We are not just travelers on the Earth's surface, we are archaeologists of time, seeking meaning in every layer of sediment and bone. Zealandia, Kerguelen, or Bigfoot, they are all pieces of a puzzle that remind us to remain forever curious and humble before nature. The next time you look at the horizon, remember that beneath that blue veil might sit a mountain range taller than the Alps. And within the dense canopy, history is still whispering secrets that only the science of tomorrow will be able to decode. The world is still vast, and our maps are, in many ways, still just preliminary sketches of a much larger masterpiece. We may never find a Bigfoot in the flesh or see the ghost continent of Zealandia rise back above the waves. But the hunt for them forces us to look closer at biology, geology, and the very mechanics of how life survives. Science doesn't strip the world of its mystery. It simply replaces ghosts with truths that are far more staggering. An ancient bear's DNA in the snow or a block of granite in a basalt ocean both tell an epic tale of endurance against the odds. We stand on the shoulders of dead continents, looking out toward new lands that have yet to be born from the fire below. The Earth will keep moving, the oceans will breathe in and out, and the maps will eventually be redrawn entirely once again. In millions of years, perhaps the very ground we stand on today will be the mythical lost land for a future species to wonder about. So cherish this moment, this brief window where we can stand here and ask questions about the things just beyond our sight. Thank you for exploring these lost lands and lingering mysteries with us. Keep your mind open and your curiosity sharp, because the real voyage of discovery consists not in seeking new landscapes, but in having new eyes. We'll see you in the next adventure into the heart of our incredible planet.